So this video is on our review RFF number 4. And on this first problem, when you have x in the exponent, okay, two ways to think about this. If you can get the basis to be the same, get the basis to be the same like we did back in integrated 1. If you cannot get the basis to be the same, then you're going to use logarithms. A 27 and 9 are really both 3 to a power. So you could use logarithms for this, but you don't have to. So a 27 is a 3 to the third, and that is being raised to the x minus 2. And then a 9 is a 3 squared. And for this x minus 2, I'm going to put it in parentheses because this x minus 2 is the exponent raising this whole thing. Now, when I have power to power, I can multiply it. So this is going to be 3 to the, and then these can distribute and give me a 3x minus 6. And then the other side is a 3 to the power 2. And when we have the same base, here I have a 3 and here I have a 3. What has to be true is if 3 to a power equals 3 to another power, these powers must be the same. So I'm going to set these powers equal to each other. So I'm going to get a 3x minus 6 equals 2, and now this is what I'm going to solve. So that's going to lead to 3x equals 8, and x is equal to 8 over 3. Again, you could use logarithms and log both sides, but if you can get your bases the same, you don't need to use logarithms. On number 2, this is a composition of function problem. So first thing we're going to do is they want us to do f of x. So f of x is x plus 2. Okay, so f of x is equal to x plus 2. That is what I'm going to substitute into my g now in place of this x. Okay, so now I'm going to find g of x plus 2. Okay, and again, I'm going to put that in place of this x here. I'm going to get rid of that, it's a little messy. Okay, so that's going to be 3 times x plus 2 squared. Now, for the final exam, it is going to be multiple choice. So if you don't see this as an answer, that means we need to work this out. So we're going to multiply this out. Now, what you want to remember is this x plus 2 squared is really, let me just write it up here, an x plus 2 times an x plus 2. That's what we're working out, okay? That's really what this is. So you can either do a box, an area model, FOIL if you do FOIL, or if you remember your perfect square trinomial, you're going to end up with x squared, multiply these together, 2x, and then double it, so 4x, square the end, plus 4. Okay, so I'm using this idea, let me just jot it down real quick, that if I have a plus b squared, that is equal to a squared, where you square the front. You then multiply this together and double it, so it's a 2ab. Okay, ab, because when I multiply it, then I double it, because you get ab twice if you're doing an area model. And then plus b squared. That's what I did right here. Okay. So now, the next thing I'm going to do, okay, is I'm going to take this and I'm going to distribute my 3 to everything. So I'm going to get a 3x squared plus 12x plus 12. And that is g of f of x. On number 3, we want to find the inverse of this. So to find the inverse, we're going to be switching our x and y. So let me first just rewrite it. This is really a y. So this is going to be x equal 3/4 times the 5th root of 6y minus 7. And this is what we're going to try to get to be y equal. So what I'm going to be doing is this 3/4 is going to be the first thing I'm going to do. So I can either times both sides by 4 and get 4x over here, and then here this would just be a 3, and then divide by the 3, or multiply by the reciprocal, which will give you the same thing. So I'm going to be multiplying this by 4/3 and this by 4/3. So I get 4x over 3 equals the 5th root of 6y minus 7. Now I need to undo the 5th root, so I'm going to raise both sides to the power 5. So I'm going to have 4x over 3 to the 5th is equal to 6y minus 7. I'm going to add 7 to both sides, okay? So I'm going to get the 4 over x raised to the power 5 plus 7 is equal to 6y. And then I need to get rid of that 6, so I'm going to multiply everything, well, I should say divide everything by 6. And so I'm going to put the 1/6 in front of this, so I'm going to think of it as a 1/6 times, kind of like a stretch, times 4x over 3 to the 5th. And then here, this is going to be a 7/6 is equal to y. And there you go. Now, if you're not seeing that as a possible answer, then maybe they worked out 4/3 to the 5th power. So 4 to the 5th is 1024. 3 to the 5th is 243. So again, multiple choice, so you have to have the answer in the form that they want it in. So this could be, I'm going to write it kind of sideways here, 1/6. And again, this would be 1024 over 243 x to the 5th plus 7/6 equals y. So I'm kind of squeezing that in. Okay. Now, the bottom can multiply with 6. So I'm going to take 243 times 6, and I get 1458. So this is going to be, let me do this in a different color. So I'm going to be getting, and I'm going to turn this direction, sorry. So I'm going to be getting I still have my 1024. Okay, again, that was my 4 to the 5th. And this was my 3 to the 5th. I'm going to times that by 6, which was 1458 x to the 5th plus 76y equals y. Now, you can always reduce fractions on your graphing calculator. Alpha y equal 1024 over 1458, and I get 512 over 729. So 512 over 729 x to the 5th plus 76 equals y. Okay, and for that, that's an equals y. And for that, again, this is your answer right here. Get rid of that. This is your answer right here. But again, if it's a multiple choice and you don't see it, all I do is I did 4/3 to the 5th, which gave me this 1024 over 243. I then times it by my 1/6, and I got this. You can put it in your calculator and reduce. Okay, again, multiple choice, you just have to find the answer. Okay. Number 4. So on number 4, we want to find the inverse for this. So we're going to switch our x and y. So this is going to be x equal 4y plus 5 minus 8. I want to get the y by itself. First thing I'm going to do is isolate this base to a power. So that means I'm going to add 8 to both sides. So I'm going to get x plus 8 equals 4y plus 5 to the y plus 5. When I need to get rid of this, get this into the out of the exponent, you can rewrite this in exponential form. This is in log form, rewrite in exponential form. So I can go log base 4 of x plus 8 is equal to my power y plus 5. Then the next thing I'm going to do, the last thing I'm going to do is minus the 5. So I'm going to get log base 4 of x plus 8 minus 5 equals y. And there you go. So the inverse of an exponential should be a logarithm. Get your base to a power by itself, then rewrite it in logarithmic form. Okay, number 5. So on number 5, if f of x has a domain of this close bracket -6 to 11 open bracket and a range of close bracket 0 to 10 close bracket, what is the domain of f inverse? So remember, domain and range get, x and y's get switched, okay? So what that means is your domain and range get switched. So if my original domain is this, and my original range is this, what happens is my new domain for my inverse and my new range, they are flipped from here. So this is going to become, sorry, that's still closed bracket. So this domain is going to become my range, and this range is going to become my domain. Oops, what am I doing? I'm writing the wrong one, sorry. Okay, the wrong one. My range is going to become my domain. So this is going to be 0, 10, close bracket. Okay, so my domain becomes my range, and my range becomes my domain. So they asked, what is the domain of the inverse? So the domain of the inverse is 0 to 10, as we see right here. Okay, number 6. So on a problem like this, we can try to get these to be the same base. And at first you're like, yeah, 7, 14. Well, 7 to not a nice power gets me 14 because 7 squared is already 49. So don't get too excited. We are going to have to use logarithms. So we're going to undo this by logging both sides. So I'm going to take the log of 7 to the x and the log of 14. I then, because this exponent, when I take the log of an exponent, the exponent moves in front. This is going to be x times log 7 equals log 14. I'm going to divide both sides by log 7, and I get x is equal to log 14 over log 7. Okay. And I'll put this in my calculator. I'm going to do it as a fraction. So I'm going to do alpha y equal. And I'm going to do log. There's my log button right here. Log 14 over log 7. And I should be getting something in between 1 and 2. Okay. And I get 1.36. Let's say, so 1.36 is my answer. And again, this is approximation, so I should probably give squiggly equals. Okay. Next page. I'm still on the same page. Sorry, this is one page. So on number 7, what we're doing here is they want the domain of this. So if we're thinking about this graph, okay, this right here is telling us that we have at x equal -9 an asymptote, okay? And so this graph, if I was going to graph it, I'm just sketching, very rough sketch. I'm going to have an asymptote here at x equal -9. This -10 means that my graph gets moved, sorry, this -12 means my graph gets moved down 12. And we're going to get something kind of like here. So, and I don't really care about this part of it. All I care about is from here on, this is where I have graph. I have graph not at -9, but I have graph from -9 on. Okay, so my domain is going to be open bracket -9 because -9 is my asymptote to infinity open bracket. And that's my domain. On number 8, what is the equation of a circle with this center? So, and a circle is x minus h squared plus y minus k squared equals your radius squared. H and k are your center. So since my center is 1, 4, I'm going to have x minus 1 squared because 1 would make this 0, plus y minus 4 squared, again because 4 would make this 0, equals r squared. I need to figure out my r squared. So I'm going to use this point. I'm going to be using this -5, 12, putting this in for my x and y. So I'm going to have -5 minus 1 squared plus 12 minus 4 squared equals r squared. And so I am going to be getting, this is going to be a -6 squared, which is going to be a 36. This is going to be an 8 squared, which is 64. So I get a 100. So 100 is equal to r squared. So my equation, again, my equation is going to be coming from here. This is going to be x minus 1 squared plus y minus 4 squared equals r squared. Keep it as the 100 because it's r squared, not r. And that's your answer. On number 9, we want to write this as a single logarithm. So I'm going to start off with log, and these are all base 10, your common log, so you don't need to write a base here, of something, okay? Now, these things that are positives or with a plus, those are going to be on top. Multiplying, anything with a minus is going to be on bottom. So I'm going to have a fraction. Now, this 3 becomes the exponent here. So this is an x to the 3rd. And this 2 is going to become the exponent of your z. So I have a z to the 2nd. And then because of this minus here, this y is going to be on bottom, and so I have y. And that's your single logarithm. On 10, okay, we're going to be graphing this. So let me just get my graph set up. Maybe I should push this up. Okay, I'm gonna push this up a little bit. So I'm gonna grab this and I'm gonna shift it up. Okay, just so I can draw a little bit more here. Okay, so this is base 2. So what I'm thinking in my head is I'm thinking nice base 2s. So I'm thinking log base 2 of 1, log base 2 of 2, log base 2 of 4, log base 2 of 8, and so on. Basically, I want nice 2 to powers. Now, log base 2 of 1 is 0 because 2 to the 0 is 1. Log base 2 of 2 is 1 because 2 to the 1st is 2. Log base 2 of 4 is 2. 2 squared is 4. Log base 2 of 8 is 3 because 2 cubed is 8. These are the values I'm going to be thinking about. Now, when I'm looking at this, this gets a little fainter, this x plus 1, this, what makes this 0 is a -1. You can never take log of 0 or a negative. So this is going to be an asymptote. So I'm going to have an asymptote. I'm just going to draw it solid here, okay? At x equal -1. It's really like a dash line, but I just want to, so you can see it. This is going to be my asymptote. So my graph is going to be going from here out. Now, this -6 means my graph is dropping down 6. So I'm dropping down 1, 2, 3, 4, 5, 6. Again, I'm really on this asymptote. I've dropped down 6. And this is where I'm going to be doing my logs. Okay, let me get a darker, make it darker. So I'm going to go out 1. Log base 2 of 1 is 0. I'm going to go out 1, 2. Log base 2 of 2 is 1. I'm going to go out 1, 2, 3, 4. Actually, hold on. I think I went over too many. Sorry. Get rid of that dot. Okay. So I went out 1, 2. Okay, 1, 2, 3, 4. I'm right here. And log base 2 of 4 is 1, 2. So I'm going to be here. Okay. And so on. And let me just move this up a little. Oh, I'm just having issues. Okay, so move this up a little. And I'm going to draw my curve. And again, this, and I'm going to move this down. Let me grab it. Move this down. Okay, so here's my asymptote. Okay, and again, I went down 1, 2, 3, 4, 5, 6 on that asymptote, and then from here I go out. Okay, and I do my values of log base 2 of 1, log base 2 of 2, 4, 8, and so on. Okay, 11, inverse. So inverse. On this one, again, I'm going to switch my x and y. I sure like a lot of these on this one, huh? So x is equal to a 3/4 square root of 6x minus 7 plus 9. Sorry, I did not switch my x to a y. Need to do that. Okay, so I switch my x and y. First thing I'm going to do is I'm going to minus the 9 is equal to 3/4 square root of 6y minus 7. I am going to be multiplying by 4 to get rid of the 4 and dividing by 3. So if I multiply by 4, it's going to be a 4x minus 36. I'm going to be dividing by 3. And then, again, multiply by 4 to get rid of this. That's where I got my 4x minus 36. Divided by 3 to get rid of this. So I divided by 3. And I have square root of 6y minus 7. I am going to square both sides to get rid of that here. So when I square this, I am going to have 4x minus 36 over 3 squared is equal to 6y minus 7. I am going to add 7 to both sides, okay? And so I am going to get 4x minus 36 over 3 squared plus 7 equals 6y. I'm going to divide by 6. And so I'm going to move this over. So I'll just move this bottom over. Move it a little bit more. I'll move it over here. Okay. So now I'm going to multiply or divide by a 1, or I'm going to divide by 6, so it's like a 1/6 in front. So this is going to be like a 1/6 here. This is going to be divided by 6. This is going to be divided by 6. So I end up with 4x minus 36 squared. And I'm just going to clean up this bottom. This 3 squared would be a 9 times 6 is going to be a 54 plus 7 over 6 equals y. You don't have to necessarily do that. I was just trying to kind of condense this a little bit. So again, my 4x minus 36 over 3, both of these, the top and bottom are being squared. I just thought of this 3 squared, which is a 9, times my 6, so I just got that all together. And then my 7 divided by 6. Okay. And last problem. So for this last problem, we're going to write this in logarithmic form. So to do that, I am going to go log base 5 of 10. And my exponent is always what my log equals. So equals x plus 6. And that's in logarithmic form. And that would be your answer. They didn't ask us to solve it. They just asked us to write it. So hopefully you found this helpful.